So here is 5.5 part 2, which is synthetic division. And it's useful when you're dividing by what we call simple or linear factors, such as x plus 2 or x minus 3 halves, or even something like 2x plus 5. Something linear. All right? We could use a form of synthetic division. And it's a little bit different. You draw your vinculum, it's actually called a vinculum, upside down. And you load the second floor with the coefficients. So 2, 1, negative 1, 5. Now I'm dividing by x plus 3. So if x plus 3 is a factor, then x plus 3 equals 0. X is negative 3. I divide by negative 3. I change my sign. I drop the first term, and then I multiply. I get negative 6, and then I add. I get negative 5, and then I multiply 15, and then I add negative 14, and then I multiply 42, and then I add to get 47. Now I'm not doing this in class, so nobody can tell me if I made a mistake or not, so I'm going to double check myself. I dropped the 2, I multiplied, I added, I multiplied, I added, I multiplied, and I added. So what is this? All right, the last thing is the remainder. Remainders are preceded by constants. Constants are preceded by x's, and x's are preceded by x squared. So it turns out that what the original problem might look like, 2x cubed plus x squared minus x plus 5 over x plus 3 is actually 2x squared, which I think you can see. X cubed over x would be 2x squared, minus 5x, minus 14, and then we have this remainder, plus 47 pieces of x plus 3. Now I mentioned a little acronym for this. The acronym is pretty simple. It's drop, multiply, add, with a repetition of the multiplication and the addition. Because we drop, then we multiply and we add, we multiply and we add, we multiply and we add. I wish it was DAM. I could say DAM all day long. But it's not, it's DMA. Now this first one, this is a remainder theorem. A polynomial, whatever a polynomial is, notice the typo? F of x has a factor x minus c if and only if f of c is 0. That's function notation, and I know what that means to you. The super easy example is x minus 2 a factor of x minus 2? So if x minus 2 is a factor, then it's equal to 0, x is 2. Now I find f of 2 by plugging it in to that problem right there. And by God, it was 0. That tells me it's a factor. This is a factor. Because the remainder is equal to 0. I wonder what I've got in this little box over here. Oh, okay, so exactly what I wrote out already. Determine if x minus 4 is a factor of 3x cubed minus 4x squared minus 28x minus 16. So I start here. If x minus 4 is a factor, then it equals 0. X is 4. Everywhere I see an x, I become a 4. Four cubed is 64. This would be another 64. 4 squared is 16 times 4. 28 times 4. Negative 112. And minus 16. Time to put some stuff together. 3 64s makes 192. And if I put those last three pieces together, I also get 192. Could you use push buttons in a calculator? Yes. But because I have a remainder of 0, x minus 4 is a factor. And I should actually write that a little bit different because function notation is kind of the key. Because f of 4 is equal to 0, I know that x minus 4 is a factor. Factor 3x cubed minus 4x squared minus 28x minus 16 completely, given that x plus 2 is a factor. So I'm going to do my synthetic division. Throw a -2 out front. Remember, you change that sign. Load my coefficients, 3, -4, -28, and -16. And the acronym here again was drop, multiply, and add with that partition on the M and the A. Drop the 3, multiply, and add. Multiply, and add. Multiply, and add. So I got a 0. Remainder is 0. X plus 2 is a factor. Remainders are preceded by constants, which are preceded by x's, which are preceded by x squared. What I've done so far is I've pulled x plus 2, and I've reduced the polynomial down to 3x squared minus 10x minus 8. And I'm going to attempt to factor that now. The leading factor was still x plus 2. To create a 3x squared, I need a 3x and an x. Factors of 8 are probably 4 and 2. And my little pea-sized brain says they go there and there. I need the 4 to be negative and the 2 to be positive to add to that -10 in the center. And that is the complete factorization of that polynomial using synthetic division. Factor 27x cubed minus 8, given that x minus 2/3 is a factor. You could factor this using difference 2 cubes, but I'm trying to teach synthetic division. That's what this little note's here about. We're going to have to introduce something called placeholders. Notice the jump from x cubed all the way to a constant. There are no x squareds, there are no x's, and then that bad boy right there. We drop 27. 2/3 of 27 ought to be 18. And then we add. 2/3 of 18 is 12. And then we add. And 2/3 of 12 is 8. And then we add. All right, so let's talk about this. X minus 2/3 is a factor. We'll clean that up in a second. I don't like the way that thing looks. This is my second set. That's going to be 27x squared plus 18x plus 12. There's a little bit of factoring that can be done in that second set. It doesn't factor in a sense that you can break it down in a double set, but it does factor in a sense that you can pull something from all 3 pieces. I can pull a 3 from every one of those guys. Then I can do something even cooler. I can distribute that 3 right there. That'd be 3x, because x times 3 is 3. Take away 2. Then I have my slightly reduced factor in the second set, which is exactly how this thing would look if you actually did your difference of 2 cubes pattern, which was taught to you on Tuesday. Probably don't remember it. Page 3 of 6. Don't have much time. Next class is about to come in here. Probably going to skip over this one to make sure I finish the lesson. You are given the expression for the volume of a rectangular prism. Find an expression for the missing dimensions. Oh, this won't be so bad. So this tells me that x is -2, and this tells me that x is -4. And do synthetic division twice. First, I'm going to pull out the -2. I'm going to drop that 2. -2 times 2 is -4. I'm going to add. I'm going to multiply. I'm going to add. And I'm going to multiply. And I got my 0. Because the remainder is 0, I can reuse this. Only because that remainder was 0 do I get to reuse. Now I'm going to pull out the -4. I drop, I multiply, I add, I multiply, and bam, remainder. Remainder, constant, x. The final factor is 2x plus 5. All right, I just want to make sure I finish that before my next group came in here. They may just have to wait a minute or two.